Alright, should be another draftphysics.com video presentation, debatephysics.com also, which probably doesn't matter because it's frankly not on the internet. There's no point in having .com names anymore, really, right? No point, because it's all about who links to your website, not about your website being visible on the internet. But anyway, that's a Google slight. Google is evil, blah, blah, blah. So this will be on YouTube, I guess, because I'm going to address Professor Lewin from my perspective directly. Obviously I won't get any direct response, but okay. That's part of internet fun. So it just seems a bizarre coincidence that I've been making all these videos pointing out the kinetic energy paradoxes, Professor Lewin's experiment as one that can be doubtable as having any credibility whatsoever because it's overtly a free energy experiment. It overtly teaches you how to make free energy. Obviously that probably can't work because there wouldn't be millions of people trying to do free energy and failing when he's showing you exactly how to do it. So it seems like an experiment, I have to say, is completely doubtable because there's only two possibilities, really. There is free energy, or you really, cheated the experiment. You didn't do a right experiment. You cheated. So those are the two choices. I don't like the two choices, frankly. I don't like making the accusation of shenanigans. But what's my other choice? Is there some other choice? Let me know, and maybe I'll grab that one. Honest mistake? I just don't think it's possible. It's such a simple experiment. No way an honest mistake can take place. You just measure the weight of the carts. You have a technology for doing the velocity. It's so simple. You have the machinery to do it, and no other explanations possible. So I find no repeat of the experiment anywhere on the internet. Can't find anybody who's ever done it and gotten the same results. I mean, it's a free energy experiment, so I'll play the experiment. I'll point out the facts. It seems a bizarre coincidence that just when I'm doing this, I've been talking about this subject extensively, pointing out how horrible this experiment, this video is of his lecture, that he happens to just point it out, and he's aggressively unlike any of his other videos, he's just aggressively says in the video like 4 times, go watch the lecture, go watch the lecture, I do the experiment. I mean, it's bizarre. I haven't been watching his video, so it's too bad I missed this when it first started, when he first posed the question. So this video will probably be long, but I'll try to get to the direct point that's relevant to Professor Lewin, respecting his age and such. Doesn't want to watch too long a video. No, it's really admirable. He's still hanging in there, being a sport and all that kind of crap. I don't want to be looking like I'm picking on some old guy. That's inevitably how it's going to look. Can't look any other way. I really don't want to pick on old people. I'm picking on physics. I'm picking on their assumptions. I'm picking on, frankly, their delusions. All right, because they really haven't proven any of this stuff. And the whole argument is that when they do prove it, you can doubt their proof because it's obviously shenanigans. Obviously, they are conforming the experiments to their theory rather than allowing the experiments to decide their theory. They're doing science backward. Never repeated the Eddington experiment. I can say that over and over. 400, you know that, Professor Lewin, 400 times better resolution from space. And I'm supposed to believe 400 times better. You can do the experiment 400 times better from space. And they haven't done it. NASA never even thought about it. No eclipse needed, 400 times better resolution. Can you explain that, Professor Lewin? I don't think you can explain it, right? By just saying, they did experiments, it just wasn't that one. Yeah, right. Anyways, so there's just no way to win here, but I'm going to make my argument. I'm going to defend the truth. I'm going to defend logic and reasoning. And, I just can't believe there's so few people that just care about the truth. Just so few. It's just the tiniest of numbers. So in the context, let's understand. Professor Lewin is a very nice guy. He says, we'll be friends, and that's the conservation law, that we'll all be friends. And then he calls people flat earthers for disagreeing with him. Okay, it's all right if you want to be as dumb as a flat earther. It's not very friendly. Okay, so there's no way to win here, right? You know, I mean, they can call you names, you can't call them names. That's the law, right? So, I mean, this is such an upside down, silly verse that we live in that, you know, there's just no way to win. So let's just get to the experiment. Okay, so first let's play this little bit. Okay, what is the momentum after the collision? So now he's going to tell you something about momentum. Now, he said this in other lectures, you know, lecture 15, but he doesn't say it in this lecture.
In the absence of any external forces, momentum before is always momentum after.
So this doesn't mean anything. Because what they think is you can have, you know, you can have 100 momentums, and then after you create 100 momentums that way and 200 that way, and because it's a net 100, that somehow it's still 100 momentums, when clearly it's not. Clearly it's new energy in the universe, more energy. 300 momentums are now in the universe. You started with 100. So if you just simply convert momentum, the idea of momentum, into the idea of heat, which is what Joule proved overtly, right? So they think Joule had something to do with proving kinetic energy, when no, Joule did exactly the opposite. He proved the one-to-one correlation between momentum and heat. That heat is completely a momentum function. You're just converting, you're just hitting little tiny bowling pins. You're just exchanging your energy with the universe, and you're giving it away in little pieces. You might have $10 bills, and you're giving it away as dollar bills. That's it. The economy is so simple and so obvious and so true. Momentum works. Newton believed in momentum. Descartes believed in momentum. And it was only the crazy religious kook Leibniz who started this idea that somehow we have to square something. No, it wasn't broken. It didn't need Leibniz's fix. It's just a horrible history, horrible tragedy of science that they could make such a grotesque mistake and they still haven't even acknowledged it. I mean, they got plus and minus wrong by accident. They didn't get this wrong by accident. It's like they deliberately went on this crooked road. So you heard him say it, conservation of momentum. Momentum is always conserved. Well, his own experiment says that isn't true. So let's go to the experiment.
It's going to come back. So you're going to see this one come in, give you...
Hey, you know what's better than a $5,000 PC?
What?
A $5,000 PC that costs $0. It's time to get...
Yeah, it would be really...
Give you the time here.
It'd be really cool if Professor Lewin just gave up on this minor income from frickin' ad revenue. Oy. I'll pay you. How much? How much realistically is it? And I'll just pay you the money. You know, to do science with a little bit of dignity. See, picking on the old man, but it's picking on everybody on the internet. I mean, this whole idea of science for sale is just really ugly.
This one goes through here, gives you the time here. This one will come back, gives you the time here.
So the simple point is 100 momentums goes in. So he just said momentum has to be conserved. And what's going to, right in front of your eyes, is going to happen. 100 momentums are going to go in. 30 are going to go back this way. And 130 are going to go that way. It's 132 and 33 the other way. So a total of 165. So you put 100 watts into a system, you get 165 watts out. It's free watts. It's free heat. It's free calories. No matter what you convert it into, it don't work. It don't make no sense. You can't undo energy. Energy this way does not undo energy this way. Yes, you could hit two pieces of clay into each other and they have zero energy. But we all know there is no zero because all the little bits inside of the clay are swirling all over the place, creating all kinds of heat. So all of the energy got converted into heat. But it didn't disappear. There was no cancellation. So you can't say 30 this way cancels 30 of this, so it's back down to 100. That doesn't work. That doesn't make any sense. That's illogical. It's flat earth stupid.
Are they zero? Okay?
So again, I haven't seen this experiment performed by anyone else. Can't find it performed by anybody else. Anybody has a link, please provide it. It'd be really interesting to see anybody ever verifying this nonsense. And again, he put springs on things that are already elastic. So in another clip I could play of this, of a different experiment where he was doing inelastic, that is, the things stuck to each other, they bounced off of each other, and you saw the real results. Essentially, his inelastic experiment turned into an elastic experiment, and it gave you the right results, which was the two-mass object went away less than half the speed. Not more than half the speed, less than half the speed. And this experiment's going to leave at 2/3 the speed. It's impossible to leave for twice the mass to go 2/3 the speed and for you to say, I conserved momentum. Impossible for you to do that. It can't be said. It can't logically work. Again, I could create a perpetual motion machine. If this is physical reality, I can create perpetual motion. I can create a machine that will keep making more and more energy for free. Fact.
You ready? Yeah. There we go.
Okay, so 1/3 the energy came back. Okay, 130% of the energy went forward. Momentum. Okay, so in just momentum terms, 1/3 of the momentum came back. 130% of the momentum went forward. It makes no sense. More momentum. We had 100 going this way. Well, it's going that way in your image, right? It's going that way in your image. You have 100 going that way. And then what do you have? Let's just ignore the reflection. What do you have going that way with the two-mass object? You have 130 momentum. So you're gaining momentum in this direction, no doubt about it. Let's just ignore the extra 30 you could also collect. But I could easily collect the momentum forward. I just take, okay, I put a one-mass object, it's a two-mass object. Well, I just crashed the two-mass object into a four-mass object, and now I have another 30% increase in my momentum. And I hit an 8-mass object with a 4, and I have another 30% increase in my momentum. I'll just keep increasing the energy in a direction, then I just use a lever to switch the directions, do exactly the same thing, and I'll keep making energy. It's a free energy experiment. And here he is focusing your attention on it, saying this is good science. This is how you understand energy. This is how you understand how the physical universe works. When this is how you get it totally wrong, this is how you make insane, silly, nonsensical understanding of reality. So I won't explain these numbers, but the 186 should really be 246. That would be half. So in other experiments where he's done exactly the same thing, that is crashing a one-mass object into a two-mass object in the sense of having the same explosion shoot them away, it was always, he said overtly, it's always twice the mass, it has to be half the momentum. And here he is violating his own it has to be rules, violating his own statements as he points you to this video saying momentum has to be conserved. There's no conservation of momentum here unless you think it's really physically possible to create a circumstance where you have motion in one direction, then you create motion in this direction and that direction that is 160 of those motions. That is, it's going to hit things in the real universe. Again, if I gave you the simple example of a balloon or a vessel that could hold the energy, and you're putting 100 momentums in, and after the first collision you have 165, and then after the second collision you have 200 and whatever 97, and then you have up to it just keeps exponentially growing. It's illogical. All right, I guess there's no point in going any further. So the 375 is the much slower speed of the thing going back. So that's 1/3 the velocity going backwards, less than, much faster than half the velocity for the two-mass object. Just physically impossible. It's free energy. There's no other way to look at it. If you thought about it as heat, it loses. You have 100 watts in, you have 165 after the first interaction. You're gaining energy with each interaction. It's illogical. I can't believe I have to even argue this. This should already be a mistake Professor Lewin corrected years ago. It's so illogical. All right, so now we'll play him talking about this and just not making any sense at all. And that's all you can say. It doesn't make any sense at all. There's no way to make sense out of it. There's just no way. Well, let me draw it once, just for fun. Yeah, I'll do that. Just so it's really clear. All right. Should be no doubt about it, right? So he crashes a one mass object, 1 into 1, right? So this one's moving, okay? We'll just say 100 to make it easy. It has 100 momentums. It hits another exactly the same object. Elastic collision, the net product is that you have one object, one mass object moving with 100 momentums, okay? Complete conservation. This one stops, this one goes, okay? Really easy to see. The very next experiment he does now, he's going to take the one mass object, he's going to hit the two mass object. Now, if it was an explosion between these two, he would say, yes, this goes off with 100 momentums, and this one goes off with 100 momentums. That means the velocity is 1/2 here, right? That would be the simple, that's the fact he also argued is a fact. So an explosion somehow works as creating a conservation of momentum, but if I bang this into this, okay, this has 100 momentums. Now I'm going to end up with 130 momentums here. Well, I can't even. 130, okay? So I'm going to, because it's going 2/3 the velocity instead of 1/2. You can clearly understand, going 2/3 the velocity, that's 2 times 66, right? 2/3 of 100 is 66. 2 times 66, 130. Well, 132. And this will be 33. And then this comes back with 33 momentums. 1 times 1/3. So you got 33 going this way. You have 130 going this way. All right, and that's supposed to be conservation of heat or conservation of weight or conservation of movement or conservation of anything. It's not conservation. This is not equal. It's nonsense. It doesn't make any sense. It's crazy. It's free energy. Again, I could just, I'll draw it for you. All right, 2x, 4x, 5. Okay, so here I have a 1, a 2, a 4, and an 8. And then I bang it into a lever. And then I shoot a 1, okay, a 2, a 4, and an 8, okay? And I bang that into a lever. You can understand I'm gaining with each hit. I'm gaining more and more momentum, 30%, 30%, 30% going in this direction. And then the lever will just simply convert the heavy thing into the light thing. I put the light thing further out on the lever. I increase its velocity, okay? And then I just do the same thing on this side. And I'll just keep generating energy. It's not only perpetual motion, it's an energy-making machine. And he proved it with that experiment. That experiment proves this. This is logically now viable as a reality because of what he states to be an actual factual reality of the universe. It's undeniable. It has to be accounted for. This is terrible that this just goes on and on. People just keep doing this garbage, and I can't get traction one in terms of pointing out it's just so wrong. And there's just no way to save face here, right? I mean, it's going to be found to be the truth eventually. So you might as well concede the point now, clean it up, and fix it, instead of waiting until later when it'll look even worse, like you conspired to cover it up, like you were hiding from the truth, that you were running from the facts. That's how it's going to look. Like you just had to keep your lies alive. All right, so that's the momentum part. So we'll play this part. Just so bad.
I have a misconception that there is a connection between momentum and kinetic energy.
So even the idea that there should be a connection between the idea of energy and momentum, of course there should be a connection. And again, it's something that Joule proved by, dropping a weight. You could just have a standard weight. I double the weight, I double how many calories, how much heat I create in the barrel. A clear correlation, a clear one-to-one relationship between the momentum of an object, the weight of an object, and how much heat it creates. One-to-one relationship, not any kind of, if I put a lighter thing that moves faster, I generate more calories. No, that didn't happen. That's not what Joule proved.
Get super fast Wi-Fi anywhere, anytime, in 6 seconds. Do you know what the extra button...
Energy. There isn't. There is not. If I told you that the momentum of a particle is 20 SI units.
Yeah, let's call them momentums, right? But you never even gave them a proper word because they're a real thing. And that's part of the irony. We don't even have a word for momentums. Quality or quantity of motion, as Newton would call it, or Descartes. Quantity of motions. We should be calling them dollars or something because they're real things. And you're pretending the real thing is really a joule, frankly. Okay, and the rest of it is just made up. The 1/2 mv squared is made up nonsense. It has no experimental evidence defending it. It has no reasoning defending it. It can be defeated by a lever. A lever proves it to be nonsense. Maybe I'll get to that later in this video, because I might as well say it all. I might as well go through every single little bit of it to make sure you understand just how wrong this is and how stupid it is that I am, that it can't be stated and have anyone concede the point. Not anyone. I mean, not a single physics-minded, science-minded person has the integrity to defend the actual truth when it's so obvious. This isn't a complex puzzle. This isn't, this isn't even chess. This is barely checkers to understand. You just need to understand checkers to understand this.
You have no information about how much kinetic energy there is.
Yes, if you don't know the velocity, you don't know the kinetic, the relationship between the momentums, right? So, and that's the whole point, though, is that your argument is that somehow the tiny bullet, right, the 1,000 times lighter object, okay, somehow when it has velocity, it has more energy than the 2 kilogram object. Even though if you really calculate the money, it's the same amount of money. It's the same number of atoms moving a distance. So if you really just look at it as atoms moving a distance, it equals the same thing. It's the same total amount of atoms moving distance. And that's what energy really is. It's really electrons and protons moving distance, but I'm just using atoms as, just to generalize it. But that's all it is. It's all just currency, a dollar bill. And you can give one person $1,000, or you can give 1,000 people $1. And the fact is, it's the same exact amount of money. You don't square the $1,000 bill.
This is very fundamental, that I hope you realize that. Momentum and energy.
So he says it's very fundamental, and it is very fundamental. It's very fundamental that Leibniz was buried as a nobody because nobody was convinced by this stupid mv squared. And understand, for the first 100 years, this idea of kinetic energy, in the form of squaring the velocity, was 1/2 off. Okay, it said 100 when the real answer, your new modern answer, is 50. So it was way off. So it wasn't even the truth when it was argued as the truth. Then they put the 1/2 in front of it. Okay, well then they argued to use clay experiments and dropping things into sand, where I've sort of explained the obvious, Well, see, I'll show that because it's important to just draw it and show you just how silly it is to think because some particles of sand go farther, it means there's more energy. When the other thing knocks thousands of particles a short distance, and the one thing only shoots 5 particles a long distance, that somehow, because it went a further distance, it means there was more energy. There's not more energy. The other one moved more particles. 8-pound bowling balls do not knock down twice as many pins. You can see it in your own life, in your own world. You don't use 4 times more gasoline to go twice as fast. It's just nonsense. Never proven nonsense.
Relate to each other as apples relate to coconuts.
No, it's Right answer versus completely wrong answer. They're both a description of reality. Both of them are asserting the same thing. They're saying, what is energy? And you've decided to say kinetic energy. The kinetic energy formula is a representation of real energy. And it's exactly wrong. I mean, momentum is the real example. And you're pretending momentum is just some sort of ambiguous, archaic, some sort of vestigial understanding of energy, when it is 100% real and accurate. And that's why Newton got right answers, is because he was using momentum. He wasn't using F equals ma, and he wasn't deriving it into 1/2 mv squared. He wasn't doing any of that stuff. He was calculating all based on 100 momentums, 30 momentums, 60 momentums. It was all just momentum, and he got all right answers.
If I give you the momentum of an particle, you do not know its kinetic energy.
And it would be really great if nobody knew it, or nobody ever thought of it, or no one even considered it, because it's wrong. It's no such thing. It's unicorn energy. It's completely fake, unproven, undemonstrated by any experiment to exist energy. It doesn't have any reality. It's a figment of bad imagination. Imagination gone south. Worse than south.
If I give you the kinetic energy of a particle, you do not know its momentum.
Yeah, so this is just a simple point. But again, what's the point of it? Because the two things can't coexist. They're two different answers to the same question. What is the thing's importance? What is its significance? What is its energy? And again, that's the other thing you just didn't get. Just tragically, because of this stupid kinetic energy formula, maybe you didn't realize that energy is weight. We actually weigh something because gravity is actually moving us. We actually move into the earth. That's why we feel the earth pushing us back, because we actually had to push into the earth, and we can only push into it if we have a velocity. So the fact is, velocity gives things weight. Weight is momentum. Weight is heat. They're all the same thing. Pressure, they're all the same thing. Equal signs between all of them. There is no distinctions. There's just mass moving. That's all there is in the universe that matters. Mass moving.
Give that some thought.
I mean, it's just so arrogant in light of the fact that I've spent the last 6 months ripping this nonsense to pieces and doing it decisively.
There's a general misconception about these two, that they are related. They're not.
What else is there? What else is there? What is the role to play? So again, Newton did all of his physics with momentum. You're saying, it's not related to energy. Apples and coconuts are a little bit too like each other, frankly. So it's not a very good way of pointing out how different they are. Squirrels and coconuts, maybe.
Okay. So, this is the best I can do for you. I urge you, please.
Yes, so here he does it. Here he does it again.
Please watch lecture 16.
And have your brain rotted by a free energy experiment done right before your eyes. Never repeated. I'll say it again. Repeated where? Where has anybody ever shown us the free energy experiment?
In which I do exactly this problem, identical problem.
Except you combine kinetic energy into momentum and create a bastardized formula that tells you that this is the truth. So you create this nonsense math to tell you this is how the outcome is supposed to be. And funny, coincidentally, your experiment turns out that way. Even though it doesn't make any logical sense, creates an insane paradox that can't be explained. Either there's free energy or you cheat. Crappy choices.
And I work it out in the case of completely inelastic and completely elastic collision. And I give you the results. And what is also interesting then is that if m2 is larger than m1, the particle v1 prime reverses direction.
Yeah, it bounces off with 30% of the momentum going the wrong way. 30% is going that way. How can that 30% be used to make the other? So the other thing couldn't even go half as fast, clearly, because it lost half the energy going the wrong way. Again, I don't see how anybody could understand the universe in any kind of rational way if they really think something going this way undoes something going that way. That energy doesn't exist because this energy is going this way. It can't make any sense.
So when it comes in like this, particle m1 goes back like this. And that is sort of intuitive. So
again, it's only intuitive because of the fact that we can't do Newton's cradle. We can't do the conversions. We have to use a lever or some other mechanism to convert fast motions, in light things into slow motions in heavy things. Okay, they can't do the conversion. Fast things can't make heavy things go fast. Okay, and things moving. Light things going fast can't give fast velocity to heavy things. They can't do it. And they can't do the conversion. They can't make the heavy thing go the same momentum but slower. It can't do it. It has to give $10 bills. That's all it has. It can't, so you need a bank. You need some sort of instrument in the way, like a lever, to change the dynamics, so you can convert the $10 bills the light thing has into dollar bills that the heavy thing can use. So you have to use a bank to convert the currency into bills that can be distributed. That's the catch. And to be fooled by that, again, this isn't chess, this is checkers. You shouldn't have been fooled.
2 before is not moving, it's standing still. And M1 comes in, and M2 is larger than M1, and after the collision, M2 goes in this direction, but M1...
Why didn't you say M2 goes in this direction at 2/3 the speed, which is 30% more momentum than you started with?
One goes backwards. All of that is in lecture 16.
Preposterously inaccurate. Yes, it's wrong. Again, it's either there is free energy, and all the physicists were too stupid to figure it out, even though they saw him do it 20 years ago, or it's a rigged experiment, shenanigans. Those are the two choices. Pick one and argue it.
Of either one. Have a nice day. Take care. If you have any doubts about whether we are friends or not,
let me call you a flat earther, and that'll demonstrate the truth. So it's just very cute. Yes, it's very nice. You like to be friends. I like to be friends. I like the world to be a nice place where everybody can get along. But the fact is, we are stepping on each other's toes. We do, create these violations. And if we take science seriously, okay, I don't want science to be a religion. So I'm going to fight it. All right? Yeah, we can be friendly about it, but I'm going to fight it. I'm not going to sit back and just say, okay, the majority rules. You're all right. I have to be polite. I have to, restrain. No, I'm not going to do any of that crap. You're wrong. I can demonstrate you're wrong. And the truth should win. Not the lies, not the bullshit.
you really do your homework.
See, some more, implying that we all need to learn. Yeah, I'm afraid some of you need to learn. Learn a little humility. Learn how to do history. Research just a little tiny bit. You don't have to research. You don't have to scratch on Leibniz very hard. Okay, and a really ugly juice flies out. Okay, the bottle leaks something really septic. He overtly said about Newton and Descartes that their physics was too atheist. Okay, he overtly said it. All right, his agenda was not the truth. His agenda was preserving a notion of a magnificent God. It was called the living force. For fuck's sake.
because that is the strongest conservation law of physics.
Yeah, well, it's not very strong. Again, that's another experiment you've done that I can prove to be kind of fallacious, okay? Because I can just play you calling somebody a flat earther because they don't agree with you. You know.
Yes, it is the strongest.
La 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 la. I mean, that sounds a little bit like Leibniz, right? Oh, we live in a perfect world. No, we don't live in, Leibniz also believed the world was perfect. It was full of scarlet fever and all kinds of shit, and people's kids were dying all over the place, but it's a perfect world. Couldn't really do better. God is brilliant. Is that true too? Yeah, I don't think so.
Conservation law.
La 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 la. Okay, so I'm just saying, I don't want to fight with old people. I don't want to look like a bad guy. But there's no way around it. I mean, it's bad physics. And it has to be argued, and it has to be defended, and somebody has to actually get in this argument and point out how the lever is wrong. Somehow the lever doesn't prove, okay, that this is, I don't really need to do that. I was going to pause to erase. All right, anyway, I'll pause and erase and then come back. All right, so let's go through some of the experiments Madame Châtelet did that got this, that resurrected Leibniz. So in France, this rich woman, interesting character, smart, all that stuff, yes, no doubt about it. But she got involved in this physics thing, okay? She wasn't a physicist. And she thought there was something to this Leibniz thing. And so she resurrected this mv squared. So let's understand it was mv squared. So it was not getting right answers. Oh, that's not really in the... well, I just put it down here. Okay, it wasn't getting right answers. All right, it was 50%, it was 100% off, okay? It would say the answer was 100. The modern answer is 50. Clearly not very accurate. But they were certain this was the truth, right? So they contrived experiments. So one of the experiments was dropping things into clay. Okay, so they would engineer a circumstance. I'll do it sideways just because you really don't have to do it up and down. But it was a gravity experiment, okay? So they dropped something with twice as much velocity and something that with half the velocity. Okay, so this has two velocities and this has one velocity. And they would push them and, let them hit clay. And they found, okay, that the thing with the two velocities went 4 times deeper into the clay than the thing with the one velocity. Now, I can make a logical argument to you that obviously things that go faster into clay will incur, okay, less losses to friction. The faster you go into something, the more likely it is, okay, that when you have collisions, that you'll create energy in the same direction that you're going. And the slower you go into some sticky substance, the more likely your energy goes in other directions. So all that really happens for the slow thing is that the energy, it pushes this way, but it doesn't have enough energy to really force things to go that way, so they end up going like water waves. The water ends up going up because it can't go forward. It wants to go forward, but it's being forced to go up. And it's not a battery like gravity. It's not going to give you the energy back again. So anyway, so yes, so the simple logic would be, you can understand that substances, things going fast, with the first thing they hit, right, it will go, they'll be able to give it a lot of velocity. So the whole thing that decides, they both hit something, what happens? They give it something smaller than they are. They give it the velocity they have. So this is going 20 miles an hour. It'll give this almost 20 miles an hour of velocity, right? This is only going 10 miles an hour. It can only give 10 miles an hour of velocity. So you understand that the first things you hit are going much faster when you're going faster. And they're more likely to be going straighter. So, that's part of the argument. Less likely to be going off in angles. All right, the other experiment was dropping things into sand. So, I can draw it here. So you can understand that if you have a puddle of sand, okay, and you're going to drop these things into sand, you can understand that the fast thing, again, something that hits the sand fast, the little particles will be given the faster velocity, right? So they'll have a liftoff velocity. If this comes in at 20 miles an hour, this liftoff velocity will be 20 miles an hour. Obviously, something going 20 miles an hour is going to go further. But the fact is that 20 means times its mass, right? So if I multiply the 20 miles an hour times, say, a mass of 10, we'll give it a mass of 10, times that 20, I would end up with 200, right? And that's how much energy this thing lost with that first impact. So it's going to hit a lot fewer things. It's going to lose its energy really quickly, shooting things far, but it's not going to shoot nearly as many. So it'll only shoot, say, 4 things. And I could do the same thing and have twice the mass, okay, and half the velocity, and something very different is going to happen. It's just going to shoot things off at 10 miles an hour. So they're not going to go as far. But with each hit, it only loses 100 momentums. So it has a lot more things it can hit. So it sends off 8 things, okay, at a shorter distance. So the truth is, if you measure all the distances and all the masses, the fact is the two circumstances are exactly the same. The same energy is in both objects. Momentum works. This is why Newton used it, because it works. All right, and so this also relates to the bowling ball example, so I'll throw that one in just as a freebie. But you can understand the 8-pound ball going twice the velocity of the 16-pound ball. You could understand what happens to the pin. The pin is a standard, 4 pounds, let's say, 4 pounds. You can understand that the 8-pound ball can give 16. Its velocity is 16. So let's say as it's giving away the momentum, it's going to go down to 15, and this will go up to 3, and then this will go up down to 14, and this will go up to 5. So it's going to give away the velocity. It'll give away a much higher velocity. So let's say the velocity ends up being 14 for the pin. Okay, when the 16-pound ball only going 8 hits, it can only give 8. It would be the maximum. It's going to give something more like 7. So if you do the math, right, 14, 7, this one gave away, say, 100 momentums. This one's only 50 momentums. So the pin only took 50 momentums from the 16-pound ball. The pin took 100 momentums from the 8-pound ball. But it left the 8-pound ball much, much weaker. Almost half its energy went away in the first pin, where this one still has, 2/3 of its energy left, or whatever the number would be. So you can understand the logic of it. They move the same amount of matter, pin matter. The same amount of pin matter will move into space the same distances, the same amount of total walking miles. Total dollars will be exactly the same. It's just an economic circumstance. It's the same amount of money. If this has $100 and this one has $100, that's what they're going to distribute to the world. And they can do it in $5 bills, they can use it in $10 bills, they can use $20 bills. How they distribute it, because they gave somebody 20 and shot him way over here, doesn't mean it was more energy total. Okay, it just means that one has more energy, so you lost more energy and you don't have as much energy to do all the other stuff. And that you can see that in every example, in every physical example, that's the truth. All right, so let's take another pause and we'll do the lever thing again, and we'll do the, there's some other good one too, the spaceship one. It's so obvious. All right, let's also just point out I've been offering thousands of dollars to get somebody to respond to this, somebody meaningful, somebody with some sort of cachet in the pop culture, including you, Professor Lewin. You want $3,000? I'll pay you $3,000 to actually respond to the points in this video. $3,000. I'll pay you $3,000. Buy you candy or something, right? I mean, you have commercials on your video, so clearly it would cut down the need for that. But I know you've already gotten a bulk payment for to give away your dignity as a scientist. So anyway, but this is ridiculous. I really shouldn't have to keep doing this. What do I have to do? Like on a hunger strike or something? I mean, my extortion. I have to extort you people to actually make some sort of counter argument to the basic, undeniable logic of what I'm arguing here. So let's test kinetic energy on the lever, right? So you have a lever, you have increments of distance. All right, so you put a 1 mass object out here. Okay, that's a 1. Okay, and you put a 2 mass object here. Okay, and you're going to try to initiate a system that is balanced. That is makes sense. It'll last as long as I get rid of all the external crapola. I get rid of friction here, and I get rid of air resistance. In theory, like a Newton's cradle, this lever will work just like a Newton's cradle, except I can use uneven, I can use uneven masses and velocities because the lever takes care of that. So the absolute fact is, if I do this to a lever, this will balance. The 2 mass object will be seen as being exactly the same as the 1 mass object because of this extension in distance. All right, I have now made the 2 things equal as far as the balance is concerned. And when I initiate action in here, I'm going to get this will go 4 times higher. So it will go 4x higher than this object. So I've pushed on one side or pulled up on the other side. Anyway, if I initiated the back and forth action, all right, so it's 4x higher, this smaller mass will go. But when it lands, it will always land just with twice the velocity, 2x the velocity. All right, it doesn't land with 4 times the velocity. It only lands with twice the velocity because gravity is a proportional force. And you have half the mass, then you only collect half as much gravity. And so you can't collect energy from gravity as fast when you're a lighter object. That's why you move the same speed no matter what weight you are in gravity, is because gravity knows you're light or gravity knows you're heavy, and it gives you the heavy thing more and it gives the light thing less. But it's clear going to be that the mass matters. So anyway, so this will go 4 times higher than this. All right, it'll land though with only twice the velocity. So the momentum's going to be the same. You're going to have a 2 for your velocity and a 1 for your mass, and you're going to have equals 2. And over here, you're going to have a 2 mass, and you're going to land with 1 velocity. So if this was 20 miles an hour landing here, it only lands with 10 miles an hour over here. So you have 2 times 1 equals 2. You have the same momentum on both sides. The fact is, if I use the 1/2 mv squared, or vmv, 1/2 vmv, if I use that formula, oh, sorry for the drawing. My error. Okay, it keeps thinking, oh, that's the wrong camera. It's this one that's flood camera. Anyway, so if I use 1/2 mv squared, okay, then I'm going to end up with twice as much energy on this side. So if we call the energy joules and we say, okay, this side will have 100 joules, we just use any number we want, and this side will have 50 joules. Now, it obviously makes no sense that this 50 side could create 100 over here. And clearly it makes no sense that 100 lands here, but only 50 goes up over here. So I'm just saying the lever proves there is no kinetic energy. It's a nonsense. It proves it. It's an absolute proof. We should be absolutely done with this argument because it proves it doesn't work. You don't have twice as much energy going up and down over here than you have over here. I put in the energy into a balanced circumstance. The balanced circumstance will just teeter-totter, okay? And I can't say there's twice as much energy over here. It's twice as big a fire burning over here as over here. I can't say something that ludicrous and be credible. It's nonsense. I mean, and these arguments were made 300 years ago, frankly. I mean, they did it all in Latin, and they never, if you read old letters, they are a little bit convoluted and hard to understand. But the fact is, they had these arguments 300 years ago, and all they kept doing was saying, the wrong guy, because the guy was prestigious who wrote the letter, they would just say, he wins. When, no, the other guy made a perfectly salient argument why it can't be true, and they just ignored the true arguments and just grabbed hold of the one they wanted to believe in. The one that had their little living force magic that the French bitch liked, so everybody could go to parties and be happy, right? It was Vogue. They all put it on a t-shirt. It was all fun, modern science. But it didn't have anything to do with credible experiments. It didn't have anything to do with credible logic. Again, these arguments about levers were made 300 years ago. They proved it didn't work. Leibniz was buried unceremoniously because people did do this logic and say mv squared doesn't make any sense. It's silly. Yeah. All right. One more round. The spaceship argument. The argument from it don't work. Okay, so we do it once again. Rocket ship, like I said, sorry, being redundant for the people that have seen this before, but I mean, it's just such an obvious defeat of any notion. So I have an event that takes place inside the spaceship. Okay, it doesn't have any steering wheel. Doesn't really matter. Right? Let's say I just have an event, and the event is like the gunpowder of a gun, and it's going to shoot. 2 kilograms are on this side, right? So there's a 2-liter bottle on this side of the explosion, and there's a 2 kilogram. A dime is on this side of the explosion. Well, the fact is the explosion, will do what Professor Lewin would make a video showing you, right? If it's a cart, a 1-mass cart over here, 1-mass cart here and a 2-mass cart on the other side, Professor Lewin will tell you that you have to conserve the momentum and that this will leave with 1/2 the velocity of this one. This one will have 1v, this one will have 1/2 v. That's the rules of the explosion. So momentum is conserved. So we know if momentum is conserved, okay, these two objects have to have the same number of, say, joules or whatever we're going to come up with. All right, as a way of measuring. So it's 2 kilograms going 1 unit of velocity, okay, versus 0.002 kilograms going 1,000 velocity. All right, so you can just think of it as atom for atom. Okay, this one has 1,000 times more atoms, but they're all holding $1 bills, right? And this one has 1,000 less atoms, but they all are holding $1,000 bills. And that's the simple truth. And so their theory says, screw that logic. Okay, that doesn't mean anything. 1,000 times more atoms going 1,000 times slower. Oh, that's tremendously weaker, So the real truth is it comes out to this is 2 joules of energy here, and it's 2 joules of energy here. Okay, same thing. The lever works. If I can make a lever actually long enough to be 1,000 times different, 1,000 units of distance. One side is 1,000 times longer than the other side of the lever. If I could actually make a lever that didn't weigh anything that could do that, I could really do this. I could drop a grapefruit on one side and shoot a bullet on the other side. But anyway, so NASA knows this truth, okay? And the truth is, I don't have 2,000 joules over here. That's what this crazy 1/2 mv squared creates. This stupid, idiotic nonsense says there's 2,000 joules going this way and only 2 joules going this way. It says there's 2,000 times more ability to change the universe with that tiny dime than there is ability to change the universe with that gigantic 2 liters. That 1,000 times more massive object somehow is 1,000 times weaker in terms of what it can move in the universe. Well, no, of course, if I did a tug of war between these two things, I put a dime on one side, okay, with 1,000 pounds of pressure, and I put 1,000 dimes on the other side, okay, but yeah, they only have 1 pound of pressure to be able to apply. The fact is, the tug of war is going to be equal. No one's going to win. There's not going to be any victor. This side isn't going to win 2,000 times more powerful. It's not going to be, 1,000 times more powerful. It's not going to win the tug of war. It's going to be a stalemate because they have the same power. They have the same energy. They have the same ability to do work. They have the same pressure. They have the same weight. They have the same capacity to move matter in the universe. They have the same energy. Something like that. They have the same. Okay, momentum is the right answer. Kinetic energy is a daydream. It's a nonsense. It's a fable. It's a silly story. It's made up religious dogma. It has no credibility, no evidence supporting it. No physical experiment has ever been conducted that isn't shenanigans that could defend it. And it's theoretical garbage. It doesn't work in space. It's stupid. It's time to let it go. But see, they can't let it go because they've made all of their quantum mechanics has this mv squared crap all over the place. And Einstein's bent space has it all over the place. So they've polluted both theories with this stupid, idiotic, moronic mistake. And so they can't let it go because they'd have to concede, oh, we really screwed up. I mean, it's not a little mistake. It's a gigantic, colossal error. And they just have to admit, oh, maybe being smart isn't a good thing to be because you didn't do it very well. You just became propagandists for a slogan. You didn't do any reasoning to apply some rational theory. You certainly didn't do the scientific method, which is repeat the experiment, okay, and do it without a bias. Don't quote mine the evidence. You violated all the fundamental rules. All right, so that's really enough, really. I mean, there are other examples, but the lever's decisive. It's over. Got to find some fat lady to sing. That's what I need. Maybe that's all that's missing, right? Yeah. So irritating. Anyway, all right. So we'll get the hell out of here. So anyway, this has been a draftphysics.com. Here on YouTube. Okay, I did do it on YouTube as a courtesy to Professor Lewin. I mean, but yes, most of my videos are on the website now because Google is evil. Needs to be emphasized. All right, let's just do that again. I'll get the hell out of here. All right, till the next time and such. This has been a Draft Physics and DebatePhysics.com video presentation. Thank you for your attention. I did it as politely as I can. I can't imagine how are you supposed to disagree about something so obvious and simple and elemental? And, especially when it's 1 against 7 billion. Well, you know what I mean. It's 6,900,000,000 and whatever. There's 3 or 4 other people on Earth who understand how stupid this is. So depressing.